Hi everyone, today I will walk you through a real-time data pipeline designed to consume events from Kafka, enrich them using Redis and external APIs, and finally persist the enriched data in PostgreSQL. We are using Java and Spring Boot at the heart of the system. We start with the Kafka producer. Its job is to send raw event messages into Kafka. Think user activity like logins, button clicks, or actions captured by client or backend services. These messages are often JSON structured but still raw. We use the Kafka Producer API or Spring Kafka template if we are in a Spring Boot app. Each message includes a key such as user ID for partitioning and ordering. Next, we have Kafka topic. Kafka topics act like message channels. Producers write into them and consumers read from them. Messages are stored in partitions. This enables parallel processing. The order is preserved within each partition and the data is retained for a configurable period, say 7 days. Kafka here provides scalability, durability, and decouples a producer from downstream services. Next, we have Kafka consumer. The Kafka consumer listens to the topic, in this case, user events. It reads messages one by one and hands them off for processing. Each consumer is part of a consumer group, which means Kafka distributes work across multiple consumers, giving us scalability and resilience. Messages are deserialized, usually from JSON, and passed on to the rest of the pipeline. This Spring Boot consumer app is like the heart of our system. It's a Spring Boot application that orchestrates the full pipeline. We use @Kafka listener for consuming Kafka messages, Spring Data Redis to talk to Redis, Spring Web or Web Client to hit external APIs, Spring Data JPA to save to PostgreSQL. When a message arrives, we log it, look up Redis for enrichment data. If found, great, we enrich the event. If not, we call the external API, cache the response in Redis, combine it with the original message, and persist everything to PostgreSQL. Here we have this logging system, which is the ELK stack here. Every step is logged using logback. We use MDC to add user ID and event ID into our log entries. These logs are collected by Logstash, which parses and ships them to Elasticsearch. Elasticsearch indexes these logs so they can be queried. Kibana lets us visualize them so we can track things like API failures, Redis hit rates, and throughput in real time. Together, this stack gives us great observability. Here we have this Redis fast cache. Redis acts as a fast in-memory cache. The idea is that if we have already looked up a user's details recently, we shouldn't hit the external API again. We use Spring Data Redis to perform get set operations. Each entry has a TTL, so stale data disappears automatically. If the key is found, we use that data immediately. If not, we fall back to API. When Redis doesn't have the data, we call an external API. For example, user profile lookup. We use Spring Web Client or REST template for the call. We apply best practices here, retries, timeouts, and circuit breakers using Resilience 4J. Once the response comes in, we cache it in Redis with a TTL and use it to enrich the message. In enrichment processor, we combine the original Kafka message with the enriched data. This enriched object maybe it could look like something that has the user ID, event time, timestamp, username, user email, and we can use simple Pojo builder or mapper, and this is the final object that gets saved. We have the PostgreSQL, which is the persistent storage. The enriched data is persisted in the PostgreSQL for querying, reporting, or auditing. We use Spring Data JPA with Hibernate under the hood, and schema is relational. We store all key fields in a structured format indexed on user ID and timestamp. If an insert fails due to a transient issue, we retry. We may also use batching to improve performance. So let's recap how the data flows. The producer sends a message to Kafka. Consumer reads the message and logs it. Redis is checked for enrichment data. If hit, we use it. If miss, we call the external API. Redis is updated with the new data. Original and enrichment are merged, and the final object is saved in PostgreSQL. And logs track every step of this process via logback, logstash, Elasticsearch, and Kibana. This system supports real-time user activity tracking, enrichment services, low latency analytics, high throughput ingestion pipelines. It blends the strength of Kafka for streaming, Redis for caching, and APIs for metadata, and PostgreSQL for persistence. The tech stack we used here is that language Java and Spring Boot, and we have used Apache Kafka, Spring Kafka for messaging, and Redis, Spring Data Redis for cache, and Spring Web Client and Resilience 4J for API and web. PostgreSQL, Spring Data JPA for persistence, logback, logstash, Elasticsearch, and Kibana for logging and observability. This architecture gives us scalability, flexibility, and observability. It is designed for teams who need to enrich streaming data in real time with strong consistency and operational visibility.